Okay, I'm recording now.
Okay.
Um,
Cool.
okay, so I'm above the probe laser at the moment, right?
Yeah, the computer's physically above the probe laser, and the pump laser is just a little bit to that side. But all the
Okay.
pump is a periscope, and the lens you were talking about is right here. That's the 150 millimeter focuser.
Yeah.
That focuses the pump down to a spot on the grating.
Okay. So first of all, Mike, can you block one of the beams below the camera so that we're not doing a dual heterodyne setup? We just do a single heterodyne setup to start with.
Can do.
So
Yeah.
just put like a piece of paper or something in the probe.
Yep, I can do that. So I've got this just cardboard on a stand thing that I can block one of those. And I will just block it coming out of the beam splitter. So that's easy. There.
Okay.
All right, so we're now in single heterodyne.
Yeah. So maybe you can turn on the everything. Turn on the pumps and probe.
Yep.
And what sample do you have in there at the moment?
Just well, I'll put it in, but I just got a piece of tungsten.
Okay. Can you tell me which and you know already that you have you'll be able to get a signal, right, with a single this.
Oh yeah, this is our standard piece of tungsten signal.
Okay.
So it's like a single crystal of tungsten oriented, and it always works.
Right. So maybe you can load that sample.
Yep. Pump triggered. So can you see the green? Okay.
Yeah. So for this tungsten sample, which grating area are you going to hit?
Wait, let's come again.
Which part of the grating are you going to hit?
6.4 microns.
Yeah, I don't think I have a map of the grating, so I'm not exactly sure which one is 6.4.
Okay. But 6.4 gives a reliable kind of 500 megahertz signal.
Okay, but my question is, I don't think we have a map of the holographic grating.
Oh, really?
Yes, I don't know which one is 6.4.
Question then: Did I say which letter phase mask I had given you? Was it A, B, C, D, or anything like that?
I don't know.
Okay, because I'm thinking I would have given you my paired B, and I could make you a copy of this map right here.
Right, that's useful.
We just keep on the wall.
That's really useful.
So in that case, 6.4 is dead right in the middle at the top.
Is there any way of telling whether I have which phase mask I have?
Yeah, I'd say if you send me a picture of it, they're all cut from a wafer, so we'll know from the curvature of it where it was cut on the wafer.
Okay. Is there front and back to the phase mask?
Could you come again?
Is there front side and back side to the phase mask? Does it matter which way round I have it mounted?
I don't think so, because whatever it's going to hit on one side, it's going to transmit through the other, so it shouldn't really matter.
Okay.
Yeah.
But by the way, Mike, I don't know if it's possible. There's a cable coming down in front of the lens of the camera. Is it possible?
Oh, okay.
Yeah.
There we go. How's that?
Perfect.
Cool.
Okay.
Okay. So I don't have anything aligned yet. So what I'll do is get the sample mostly aligned.
How are you mostly aligning it?
So can you see down here? Can you see in this lens that I'm pointing at? Okay.
No, because there's something
let me
blocking
move
it.
the computer over. Let's see where to put it. It's a tight setup for sure. Let me see at what angle I could put you. That stuff out of the way. Let's see. So there you're looking at, okay, the sample's blocking the thing. Let me get you like a book to prop this up on so you can see what's in the lens. Hold on. Okay. Let's see. Okay, so can you see the two beams right where my finger is here?
Yeah.
So what I'm trying to do is I'm going to unalign it right now, and you'll notice that there's a pair of beams that I'm moving,
Yeah.
and what I'm trying to do is get them to co-align
Yeah.
with the ones going in. And when you do that, it means that you've effectively got a one-to-one imager where the beams going in are the beams coming out.
I see.
And
Yeah, I
that's about
understand
as
that. I think you showed me that before actually. How important is it? How important is it to have the sample in the focus?
extremely. So, I mean, at this step, not necessary, but eventually you're really aiming for about 100 micron ellipse in free space. So it's very important.
Okay, how do you find the focal position?
The best way I do it is I'll lift it up so that the incoming and outgoing beams are on top of each other. And I look carefully at how spaced apart they are. So you can eyeball it to pretty close by making sure that the incoming beams and the outgoing beams are
Okay,
spaced the same
sure.
amount.
And then after eyeballing it that way, then how do you
Yeah.
find the focus?
Then you just have to sweep
Tweak it.
back and forth a little bit. But so what I'll do now is, I mean, I can see that the focus is a little off. My outgoing beams are a little narrower than the incoming. So I'll pull the sample back, and now they're, to my eye, from looking above, they look to be exactly collinear.
Okay.
Like from my vantage point right here,
Yeah.
looks like they're right on top of each other. So now I'll tilt it down so that they really look collinear. And usually here we're extremely close.
Really? Then what
Yeah.
do you do to check
Then
the
I'll turn on the probe laser. It's going to get a little louder. So at this point, I'll start looking at the scope.
Okay,
So can you see that
before
okay?
you, yeah, I can see the scope, but um, okay. So what do you have? What channels are you using here? What's going into channels 1 and 2? Is those just the two detectors?
Sure. So channels 2 and 3 are our negative and positive signals, so the two heterodyne ones. And channel 4 I'm using as the trigger.
So you're triggering off what?
So I have the RF generator
Yeah,
being sent to the pump laser controller,
yeah.
and the output of the pump laser controller, which is just like a pass-through, this cable here goes into the oscilloscope.
That's pretty much what we've got. We've got the same.
Okay.
Yeah.
And it seems like my students looks like they might have screwed something up. Too many averages, so just
How
bear
many
with me while
averages
I
are you
fix
using?
what they've done.
How many averages are you using, Mike, for this alignment step?
Sorry, come again?
How many averages are you using for the alignment step?
100 for now,
Okay,
because that seems to be a good balance between getting a good signal and it responding quickly.
right. And then so what's for the pro detector, what is the scale you're using for the oscilloscope voltage?
Yeah, so I'm doing 5 millivolts per division to start.
Okay, and what about the time base?
The time base is 20 nanoseconds with an offset of minus 92 nanoseconds.
Okay, so the offset is, so does this mean that you start to see the signal? Sorry, 92
Yeah,
nanoseconds,
it
did you
means you'll
say?
start to see the signal about here. And that way you've got the most room for the signal to actually ring.
Did you say 92 nanoseconds offset?
Yep. And that's part of that it's characteristic of your system. So what I'm going to do here is zoom out. in the time base. And what I expect to see, if things are aligned okay, I'm going to zoom out to 50 microseconds. And we should see, well, if it were aligned right, we would see the pump hitting the detector in this wild up and down oscillation, but we don't. And that tells me that one of my students has screwed it up.
Okay, that's a good thing, right? Because then we can
For
see.
us, yeah, for the debugging purposes.
Yeah.
So that's that. Now I'll put you back here and show
Yeah.
you how I get this alignment in the first place. So I've got here this this IR card for
Yeah.
visualizing the probe beam.
Yeah.
And so what I'll do is block the pump with something. I guess I've got an old aperture I can just shove in the way. And make sure that the probe beams are actually hitting the sample. So I don't know if you can see that.
I can't, but it doesn't matter.
Okay.
You can explain it to me.
But luckily I do have probe beams, although ascertain precisely how it's been screwed up. That's always a question with these folks. Let's see. Oh dear. Why is that so low? What is going on here? Sorry, can you bear with me just a sec?
Sure.
Things may have got more screwed up than they should be. That's a better spot. So there's our probe beam, nice and strong. Oh, what the heck? Someone has very incorrectly removed the ND filter altogether. So I need to, just let me fix this real quick.
Someone borrowed your ND filter.
Oy, oy, oy. So somebody has done this.
They've
They've
broken
clipped
it.
the ND filter on the wrong side. So it should be, what the heck?
What do you mean it's on the wrong side?
So it should look like that. So that this way, if you flip the ND filter, you just get the different one. They had clipped it pushed up so far that it wasn't even blocking. It wasn't in the beam.
I see.
So that's a silly mistake there.
We're using a disk ND filter. That,
Okay. Yeah, that should be okay.
yeah.
All right, that's better. And it's massively misaligned. So I don't know if you can see where I am now. So I'm taking the card to try to put it at the detector, and the spot is like very far off from the center.
Right.
So I'm going to use this pick-off mirror
Yeah.
and this one to try and push the spot towards the center of the detector.
Sure. So Mike, you don't have any lenses. Do you have any lenses in between your before your APD?
Any what? Sorry.
Is there a lens to focus the light into the APD?
No, we don't need it.
Oh.
So the only thing in front of the APD is a line filter. just to block the green light.
Sure.
So.
And that's enough, is it? I assume we've got the same line filter as you, but that you don't have any of, you can't see any of the green coming through on this 5 millivolts per division.
Yeah, so it's almost invisible. Sometimes you see a little bit of a green pump spike, but it's workable.
Okay.
So what I'm going to do now is the one thing that the safety folks tell us not to do.
After the green pump spike that you can just about see, how many nanoseconds do you have to delay before you see the signal?
So the spike only lasts a couple nanoseconds, and typically will collect for 200 to 500. So there's plenty of signal.
So the beginning of the crosstalk from this green laser, that's exactly the same position where you start to see the oscillations, right?
Yeah, it is. Yeah. So right when the pump fires is also when the oscillations go, but we usually toss the first oscillation because it's mixed up with all sorts of other things.
I see.
And we'll start the fit on the second or the third.
Okay.
Yeah. So I'm going to do the one thing the safety folks tell me not to do, and look directly into the detector where the lasers are, because I know where the beams are and they aren't, and try and get it on the spot. So I'll pull out the line filter so I can actually see the probe beam, and then try and point it on the active area of the APD. Yep, as suspected, we were way off.
I don't understand how you can see the probe beam when there's no IR card there.
So you can barely see the probe. It's at 785. It's at the edge of human visibility.
Yeah. I have also seen it with my eyes as well, but I'm assuming that's just because it's like stupidly powerful amount of light.
It is very powerful, yeah, and like we shouldn't do it a lot. Now, this is odd. Normal, auto. Oh, I forgot to turn the detectors on.
Oh, that'll be it.
Ah, beautiful.
Can you show me?
Okay. So this is what we're looking for. So when you're off spot, there we appear to be on blue. Let me hide the blue, because we're only going to try for the red channel right now, because we're not doing duoheterodyne.
That's right.
So that's all we'd be going for. And if you're off spot,
what are you varying at the moment? What do you control? What are you changing?
So I'm changing the alignment. I'm basically intentionally misaligning the probe into the APD. And then as we hit the active area, you can see the chopper wheel turning on and off the signal, and it should be massive.
Yeah.
Like enormous.
Okay, Mike, stop there. Stop. Go back a bit. Go back a little bit. Go stop there. So maybe go back. There. Stop around there. Can you see these oscillations just before the second peak?
Oh, so this is on a 50 microsecond time base. So this you won't be able to see any of the SAW signal. So now that we know we're close.
We see these oscillations and we see these things, but we know that that's not what we're looking for. But I was just wondering if you know what it is.
You mean these giant things?
Before that.
This thing?
Yeah.
I don't know. I don't know what that is actually.
Okay.
It's not our signal because it's far too far away. Like if you notice, then when the APD comes back, there is kind of decay and damped oscillation here, and that to me is the APD effectively coming up to charge, because it went from totally off to totally flooded, and trying to find a new equilibrium to get the AC part of the signal. It's an AC coupled APD. So eventually, if you just wail on it at a constant light level, it will give you zero signal, but it takes time to get there.
So your setting on the oscilloscope is also AC coupled, right?
Yes. Anyway, so I'm going to zoom back into our 50 nanosecond time base. because we're probably close to a signal now.
So that was 20 microseconds, was it?
Come again?
That was 20 microseconds.
The 50 microseconds.
50, the previous was 50, okay.
And so now we're at 20 nanoseconds, and we already have some signal right here.
I can't
That
see.
means we're
Change
quite
it to some
close.
glare there. Can you change? Because of the glare.
Right there. In fact,
Mike,
if
can you
I
change
play
angle
with
because
the
the computer
alignment.
has glare. Mike?
Yeah?
Can you change the angle of the monitor slightly? Because there's a bit of glare and it's difficult to see the signal. Well, that's
Is that better?
worse. No, it's worse.
That's going to be even worse, right?
Yeah.
Let's see.
It's because of this orange light from the laser, I think.
Oh, okay. Let me see that. Yeah, let me hide that a bit. Push it back. Is that better?
Maybe, yeah, maybe.
Okay.
Sorry, Mike.
No problem.
So now what are you varying?
So let's see. So
what are
now,
you changing, Mike?
Just the alignment, the pickoff mirror. So the same thing I was doing before. I haven't touched any new knobs. But if you look here, that is a surface acoustic wave signal. And in fact, if I make the averaging larger to maybe 1000, you'll see it crisp right up. So if you notice, the alignment that I did just by getting the two pump beams to be coincident, it actually worked perfectly. Like, we're done.
Wow.
Yeah.
Wow,
This is about as clean of a signal as I could ever hope to get.
And the only thing you were changing just now was the alignment of the probe laser into the detector with the pickoff mirror.
That's right. So if we go back here, let's see. So just by getting these beams to be coincident in the same spacing,
Yeah.
I've found the focal point clearly, and I didn't have to do any other twiddling in order to get it.
That's crazy. Well, can you show me what you would do if you weren't so lucky just now?
Yes, can do.
Oh, and sorry, before you do that, Mike, sorry, I've got lots of questions. Mike?
What?
Sorry, before you do that, can you just
Yeah.
confirm that you were just changing the pickoff mirror for the probe laser you were just tweaking it so that you could get the probe laser into the photo detector slightly better, right?
Yes, confirmed. I didn't adjust anything else. No phase adjust, no positioning, no nothing.
Okay, sometimes if the phase wasn't perfect, you would have to adjust the phase as well at that point, right?
That's right. And I'll show you where I would do that and what it will look like.
Okay.
So let's see where you can see. So the phase adjust is right here. And this is just a glass slide that tilts up and down. I mean, you won't be able to see the action because it's so small, but I'll show you what it looks like on the scope. So right now you can see our signal. I'm going to go back to 100 averages, just because otherwise we won't be able to watch it change. And as I play with that phase adjust, you can see the signal flip to go higher or lower.
So if you were aligning it and it wasn't aligned, the phaser just happened to be in a bad position, you would twiddle both the pickoff mirror, and you would also adjust the phase adjust at the same time.
No, so luckily the phase adjust moves things so little that you can independently align those. You can get the pickoff mirror to the point where I like to say it gets the most sparkly. So let me do that as an example. I'm going to put the phase adjust in the worst possible position.
Yeah.
Right in the middle. So you might not know that that's a signal, right?
No, there's nothing there.
So what I would do is you might get something like this where there you can see the pump spike. and I'll just play with the pick-off mirror until you get sparkly, like where it just goes nuts like that, right?
Yeah.
And then I'll go further, and then, okay, it disappears, so I've clearly missed the middle. And I'll just go back and forth and make the sparklies as big as I can. And then independently, then you can play with the phase adjust. And as long as anything moves with the phase adjust, it means you're good.
I see.
Because the phase adjust will do nothing unless it's aligned.
One problem that we have at the moment is we can't even see the probe spike, sorry.
Oh, okay. Do you see the sparklies, though?
I'm not sure.
All right, let me think. So I'm also trying to think what's the earliest I could feasibly come over there and help. Because that's something I would like to do. The reason I'm not willing to until the masks come off is the number of times I've shot myself in the face aligning lasers with foggy glasses.
Yeah.
It's just plain old. Unless you thought like we could be in your lab and nobody would come and look and haul me off to jail. I'm just very wary of aligning things in a mask because the number of times I've been shot in the face.
Yeah, I think I also, pull my masks down when I'm using machinery and things, wearing safety goggles.
And do people yell at you or do they understand?
No, because there's no one around. So if there's no one really in the lab, there's no danger, right?
I would think so. I've heard these stories of people going to jail for not complying. I mean, there are people in prison now for not wearing masks, which is why I'm so reticent. I mean, here nobody cared.
Yeah, I think the first thing to do, we're really serious about Glenn coming to you for a few weeks.
He can come anytime.
Yeah, so I think sometime maybe towards the end of this month or early next month.
Okay.
Just for a couple of weeks.
Yeah, I think. So anyway, I know it may be a little disheartening that I just kind of jumped on and with 2 alignments, we've got a signal going. One thing too is, did you guys get a beam imager yet?
Yeah, we just have a CCD camera that works quite well.
And are you able to see the grating in the beam imager?
I'd be interested to see what your grating looks like in the beam imager. We can definitely see stripes.
Okay, and are they about the right? Here, let me go to a slightly less noisy place. Are they about the right wavelength? Like, are they?
I don't know what the right wavelength says. You mean because we don't know what we're. I can't. To be honest, I have to check with Glenn what the pitch of these stripes actually is.
Yeah.
But you're saying we should be aiming for around 6.4 microns, right?
Exactly. Yeah. So I think if you look in assuming you've got one of the B phase masks, which I think it might have said so on the box, if you've still got that. And if not, let me know. But if that's the case, then the 6.4 microns is dead center of the grating. Right. So all I'd try first is to see if you can image either the pump or the probe and get like if you can confirm coincidence of all the beams using the beam imager. So I had to do a complete realignment of the system because somebody really screwed it up. And using the beam imager, I was able to make sure that the pump and the probe overlapped in space and very well. That was the enabling thing that made this all work.
Yeah, we have actually done that, and that was quite useful, I think, being able to see where everything's hitting. And also, Glenn is being quite careful to reproduce the same sizes of spots as that you're using the beam imager as well.
Oh, good. Okay.
Yeah.
Yeah, so I think that's I know it's disheartening to see it just kind of pop up though when the spots are coincident, and like if they're coincident on the grating and in that focal place, if you get the incoming and outgoing beams to be perfectly collinear, you are aligned. And then it's just a matter of sending the last beam back into the detector.
Yeah, we just can't see that probe spike. That's I've never seen that. I mean, I can speak to Glenn. I'll share this video with him to see whether he's seen it. But I don't think I've seen it before.
What's the high frequency cutoff of your APDs?
We have the same one as you. We have the Menlo Systems one, which we're not using, and then we have one APD, which is exactly the same as yours, the Hamamatsu.
Oh, good. Okay. Yeah, so I think, oh, I just got a note from Teams saying they're kicking us off in a couple minutes. So, and I may have a visitor outside in a sec. So, I think next order of business is let's get Glenn here as soon as we can.
I agree. I think this has been actually quite useful. There's a few tips that I've got and a few things I want to try with Glenn from this video. But if that really doesn't work, then I agree. It's best to let Glenn come over and play with your system. Maybe you completely mess it up and ask him to align it.
That's okay, because now at least I know how to do a complete realignment from scratch.
Yeah. Okay.
Cool.
I think it's been useful anyway. Again, I can share this video with you and you can do with it what you like. It might be useful for other people, I guess.
Oh, sure. And I think I'm up for doing this again. And I think next time I'll bring a little handheld webcam so I can get your view way into the lenses.
That'd be useful. And if we have to do it again like that, I will also get Glenn and Matt involved.
Sure. Okay. Yeah, I know I've got webcam somewhere. I'll just make sure to bring them in and a good microphone. So, yeah, I realized that the lab and little laptop speakers don't work so well. So I think what I'll do is I'll get like a Bluetooth headset, so I don't have to be connected with a cord, and a webcam, so I can get you right up into the lenses and see what I'm doing.
Thank you. But I want to try a few things that I've noticed what you were doing today. Even the simple settings for the oscilloscope, understanding where we should be looking and the graph, the plots that you were showing, and the averages that you're using. All those tips we had really no idea.
Okay. Yeah, and then one of these times that I'm happy to sort of be your eyes and you be my hands on your setup, and we could do that again too.
Okay, that's good as well. Maybe that's what we should do next.
Cool. Okay.